welcome back to my vlog. It's me, Efren. So today we are going to talk about matter, energy, and cycle. So are you ready?
Let's talk about matter. Everything around us is matter. The book that we read, the air that we breathe, the water that we drink, and etc. These are all made up of matter. So whether the living thing or non-living that has weight and occupies space. Thus, we say everything that has weight and occupies space is called matter. Matter is made up of tiny particles called atoms. These are so small that we cannot see them. These atoms usually join together in a small group called molecules. A water molecule is made up from a pair of hydrogen atoms joined to an oxygen atom, so the composition as shown. All matter can be classified to one of the three groups: elements, compounds, and mixtures. Elements and compounds are pure substance. An element is matter that is made up of only one ingredient. Carbon, oxygen, hydrogen, nitrogen are non-metallic elements. A molecule of hydrogen gas is formed when a pair of hydrogen atoms join together. Copper, gold, silver, iron are metallic elements. Pure elements are found pure in nature. They usually combine with other elements to form completely different materials called compound and mixtures. In a compound, the elements always join together in a fixed ratio. Compound can be separated into their elements, but an element not be broken down to anything simpler. Mixture. These are the two or more substances mixed together. Physically, ratio is not fixed as they are not chemically combined. Mixture is a substances that can be separated by physical means and retain individual properties. Wet sand is a mixture of water, air, and grains of sand. Seawater is a mixture of water and salts. All solutions are mixtures. Now let's proceed to states of matter. State of matter is determined by the way molecules are arranged in the substance. Molecules in solids are tightly packed, giving them a definite shape and a fixed volume. Molecules are held together by extremely strong bands. In liquids, the molecules are loosely packed such that they do not have a definite shape but do have a fixed volume. Molecules' bands are weaker. In gases, the molecules are very loosely arranged. Gases have neither a definite shape nor a fixed volume. Gases occupy all the available space. The gas molecules are full of energy and keep bouncing around constantly. The bands that try to hold them together break easily. Now let's proceed to the change of state. Water is the only substance on Earth that naturally occurs in three different forms: as ice, solid state, water, liquid state, and water vapor as gaseous state.
Everything around us is energy, from the cars that we drive, to the electronics that we use, to the food that we eat. Everything, literally everything is energy. In physics, energy is defined as the capacity for doing work. Energy is equal to capacity for doing work. This definition requires examples to understand what work means, so we'll cover some of the forms of energy. And these are the multiple forms of energy, but they can be simplified into two forms of energy, the kinetic energy and the potential energy. So for example, your car has mechanical energy. It's an object in motion when it is moving. How does it get that energy? It gets it from the gas in your car, which is chemical energy. It's potential. It's been stored until it's released as energy, which allows your car to move. Now I'm going to give a couple examples of how energy can be used to do work. And in these examples, they're purposely using particles that you see here. And this example of conduction of heat. It's air molecules that are vibrating and heating up, causing the motion of these particles. Now the thermal energy. Thermal energy can be used to do work. For example, to cook food. It is an example of kinetic energy. Now, nuclear energy is potential energy. It's stored energy in the atoms and the nucleus of an atom, and it can be used to do work. For example, if it's split and that energy is released, and that work could be used to spin a turbine which generates electricity, and that's what happens at some nuclear power plants to generate electricity for our home. But the key rule in physics that energy is always conserved. You can see here that examples of the roller coaster car, and energy is always conserved. It's always 100 there, but yet potential and kinetic energy changes, and this is a clue. It's a huge clue really, that there must be a common source of all energy, one that can change forms. Now, I have to ask you again, what is energy? So we use an analogy here. It's much easier to have analogies, so there's things that we can see when we try to compare the world that we can see. So imagine a pool of water, right? And this pool is flat and motionless. There's no energy in the pool. Next, imagine an earthquake shakes the pool. Now we can see that water is moving in all directions in forms of waves, right? The pool has energy and it can do work, it can move objects. Now let's imagine a universe that has a medium, right? The medium is the same thing as the water wave in the pool, but in the case of the universe, it's referred to as an ether, and if an ether exists, it could be described the same way as the pool. Energy is the motion of the ether which travels as waves. Waves have four simple properties. The energy in any volume can be calculated based on these properties. Now the nice things about waves, they have the four simple properties, and energy can be calculated based on these four properties for any given volume. So another nice thing about waves is that waves have two directions of vibration, and that's relative to the wave motion. One is called longitudinal, which the vibration is in the same direction as the wave, and the second is transverse. The particles in this case are going up and down in right angles in the direction of the wave motion. And you see longitudinal and transverse here have associated some forms of energy. This accounts for the basic properties of kinetic and potential energy. Now, another nice property about waves so two types of motion. One is traveling distinct, whatever one would expect from a wave. A wave that is in motion, well, there's also something called standing wave, and not standing wave as a result or aware that's being reflected. Think of it as an aware bounces off something it's reflected as an out wave, and the combination of those waves, if they're at same frequency, produces that's called standing wave. It's a wave that is stationary. Waves can change form and motion, but its energy will always be conserved. The universe can be modeled as waves of energy flowing through the ether, the single source of all energy.
Cycle is a series of events that regularly repeat in the same order. This makes it perfect to use it for building routines. Routines are also repeated actions, making them a perfect fit to build them on the top of the existing cycles. The first step is to identify the cycles that already exist. These are usually the repeated time intervals that stay consistent, like days, weeks, months, quarters, or years. Every day is a cycle. We wake up in the morning and go to sleep at night. And during this cycle, we often perform the same actions. Also, our energy levels are for the most part distributed throughout the day, following the same pattern. I personally have more energy in the mornings. For that reason, I plan my most important and hardest activities in the first part of the day, when I'm most productive. So you should use your daily cycle to build the routines that will help you to become more productive and perform at your best. The next cycle is a week. Every week starts with Monday and ends with Sunday. You also most likely spend week in the same way. You might work Monday to Friday, cook your meals every Monday, Wednesday, Friday, and have a day off on Sunday. This makes the week a perfect cycle to build a structure in your life, so be sure that you allocate some time each week and sit down to plan your upcoming week's activities. In the same way, you can use months to focus on a specific project, use quarters to achieve specific goals, and use a year to have a clear vision